All right, welcome back to the deep dive. Today we're getting into some pretty high-stakes stuff. We're looking at audio, video, and IT
The
infrastructure.
kind of systems that just cannot fail.
But exactly, and what it costs to guarantee that uptime. We've got some source material here on the tvONE ONErack redundant power solutions.
Right.
So let's just unpack this. What does a piece of equipment like this, the 1RK-PSU-HSWP, tell us about, the real difference between a normal power supply and a truly mission-critical one?
Well, it tells us a lot.
If you look at the specs for this thing, it's a $700 dual redundant hot-swappable power supply. It's designed to sit inside a ONErack chassis. But the thing that immediately jumps out at me is the wattage. It's listed as a 250-watt power supply, but then the docs say it can deliver up to 450 watts. That seems like a huge gap.
And that gap, that's actually where the whole insight into mission-critical engineering is. I mean, that's the story right there.
Okay.
You see, the 250 watts is what the system needs. That extra 200 watts, that's the critical headroom.
Headroom, right.
So if you have two of these units, and one of them fails, the other one has to instantly take on the full load without even breaking a sweat. That extra capacity is the safety margin. It's what guarantees seamless operation.
So it's not just about having two, it's about one being able to do the work of two in an instant.
Exactly. I mean, think of it like the dual engine system on a commercial aircraft.
Okay, that makes sense.
The point isn't just that there are two engines. It's that the switchover is so instantaneous. It's like it never happened. And that term hot swappable, it means you can literally pull out the failed power unit and plug in a new one while the whole system keeps running.
No interruption. Ever.
Never.
So that covers the backup engine. But the sources show that true mission-critical performance is also about preventing the failure in the first place. I mean, if it's already dual redundant, why all the extra stuff? Built-in fuses, surge protectors. Isn't the second power supply the ultimate protection?
That's a really important question. The second unit is what we call reactive recovery. But all those other features, DC power conditioning, load sharing, that's proactive prevention. DC power conditioning, for example, it cleans the electricity before it even hits the delicate components. It filters out any noise or tiny fluctuations that could cause micro-failures over time.
And what about that term load sharing? It almost sounds like something for project management, not hardware.
It's absolutely vital here. Load sharing makes sure both redundant units are splitting the workload perfectly evenly.
Why does that matter?
It prevents something called asymmetric aging. If one power supply always works just a little bit harder than the other, it will fail sooner.
I see. So you don't want one to fail and then the other one, which is already stressed, to fail right after?
Precisely. We're talking about protecting things like modular matrix switchers or high-end AV over IP setups where a single drop signal could mean losing a live multi-million-dollar broadcast.
Or a critical medical feed.
Or a critical medical feed. The stakes are incredibly high.
And that really puts the $700 price tag into context, doesn't it? It's not just the internals. They mention ease of maintenance, 2 locking rear outputs, a front power connector for that easy hot swapping.
And we should probably mention it's TAA compliant.
Right.
Which means it meets the strict sourcing rules for, secure government or military installations. So even the supply chain itself is part of the reliability equation. This unit is $700, but they have larger ones that cost up to $1,750.
Wow.
Meanwhile, a standard, non-redundant supply is still over $600. That premium is for reliability.
So if we connect this all to the bigger picture...
The bigger picture is that the willingness of these industries to pay hundreds, even thousands for peace of mind just shows that the cost of lost data, lost revenue, maybe even the lost lives, it far outweighs the investment in the architecture.
So what does this all mean for you, the listener? I think the key takeaway is that true reliability isn't just about having a backup plan.
No, not at all.
It's built into the architecture itself through these specialized proactive layers, headroom, load sharing, power conditioning, long before that backup is even needed.
Well said.
And this raises a pretty important question for you to think about. Considering that comparison to a dual-engine aircraft, how many of the business tools you rely on every day, from your cloud hosting to your internal servers, are actually built with this level of engineered, redundant protection? And are you currently paying for that crucial reliability gap?